In this lecture, we will cover important practices for creating reliable and effective software. It starts with style automation, explaining how tools can automatically enforce consistent coding rules, making projects easier to manage. The lecture also focuses on portability, showing why it is important for software to work on different platforms, like various operating systems, hardwares, and browsers offer simple tips to address common challenges. In test coverage, different methods are explained, such as branch and path testing, to ensure every part of the code is checked. The lecture also discusses difficult testing scenarios like handling system errors, race conditions, and performance issues. The Beyond's rules remind us to test features we care about to avoid issues during big changes. Finally, the lecture explores aerospace testing, showing how structured methods like unit test and hardware in the loop testing ensures the reliability of the critical systems. Let's start with style automation, which help enforce consistent coding styles across our projects. Here are some advantages of the style automation. Like no human effort is needed once rules are set. It ensures a uniform coding style, reducing misunderstandings. Automatically apply rules even after changing, like refactoring. Update the whole code base when style rule changes. Along with the advantages, there are some disadvantages like it doesn't allow handle complex style rules well. Handling exceptions can be awkward. Changes can clutter way on history. Now, if we talk about the style guides, so here are some examples of the style guides which include Google Guides for C++, Java and Python, as well as Motor Industry Software Reliability Association for C or C++. When creating and adopting a style guide, it's important to ensure that it explains the reasoning behind the rules, avoiding risky practices and enforces best practices. The guide should also be simple enough to allow for automation of rules, ensuring consistency and efficiency in coding standards. Now let's move into the portability, which means ensuring your software works on different platforms, architectures, and environments. Here are some advantages of the portability, like it increases your customer base and future-proofs your software. It reduces hidden assumptions and improves your development process. It using different tools and compilers often uncovers hidden bugs. Also, there is a challenge in portability, like maintaining portability. Portability can be a lot of work. Key targets for portability in software development include ensuring compatibility across different hardware platforms such as x86 and ARM, which may have different instruction sets and architectures. Additionally, the software should be function seamlessly on various operating systems including Windows, Linux, and Mac OS, each with its own system libraries and conventions. Browser compatibility is also crucial, ensuring the software works consistently across major web browsers like Chrome, Safari, and Firefox, which may interrupt web standards differently. Lastly, it is important to account for various compilers and interpreters, as differences in their implementations can impact the behavior and performance of the software. Now let's talk about the testing, which ensures that software works as expected. Now let's talk about the goals of the testing. So the goals of testing is basically to find and prevent the bugs, make it easier to maintain and refactor code, and clarify how the software is supposed to be used. If we talk about the good test, then good test should be bug free, it should be easy to update, and it should be well documented and understandable. Test coverage is a metric that indicates how much of your code is tested through various testing strategies. Function coverage ensures that every function in the code base is executed during testing. Statement or line coverage verifies that each line of code is executed. Branch coverage examines whether all the possible branches in the decision points are tested. Condition or decision coverage goes further, ensuring that individual conditions within decisions and their outcomes are validated. Loop coverage ensures loop execute for different scenarios such as 0, 1, and multiple iterations. Lastly, path coverage ensures all the possible execution paths in the code are tested to identify potential edge cases. Testing can be challenging in certain situations. For example, it can be tough to test system errors like running out of memory or disk space. Issues like race conditions in the programs that run multiple tasks at once are also tricky. Portability problems where software behaves differently on various platforms added to complexity. Additionally, performance issues such as slow disk or network access are hard to recreate and test effectively. The Beyonce rule is basically if you like the functionality, you should have tested it. This rule ensures accountability during big changes. Use abstraction to stimulate challenging scenarios like out of memory errors. Tools like Valgrind and fuzz testing can help uncover hidden issues. In aerospace testing, a structured approach ensures reliability and performance. Unit tests focus on through coverage and verifying independent implementations. Smoke tests validate configurations through small-scale integration testing. Regression tests catch behavioral changes to confirm refactoring doesn't affect functionality, ensuring control algorithms meet missions objectives. Medium-scale integration tests like software in the loop use virtualization, preloading, and hardware simulation to test the subsystems and end-to-end functionality. Hardware in the loop test assesses large-scale integrations to verify non-functional requirements, while vehicle in the loop testing ensures production units meet standards. Formal test deliverables encapsulate all the results for review and compliance. Thank you for watching, and I hope this helps you in your software development journey.